We have next example. First, we have to find the domain of our function. We see that we have here the power, we have addition, multiplication, subtraction. We can subtract, add, multiply every real number. It means the domain of our y function will be all real numbers. Next, to find maximum and minimum, we need to find first derivative first. So we have y prime is equal, derivative of 7 is 0, derivative of negative 3x is negative 3, derivative of x to third power is 3x squared. So we can rewrite this. This is equal, and start from highest power will be 3x squared minus 3. We have first derivative. When we have first derivative, we have to solve equation when the first derivative is equal to 0 to find critical values. So we have y is equal to 0 if and only if we have 3x squared minus 3 is equal to 0. We have to solve this quadratic equation. So I will move negative 3 to the right side. So it will be 3x squared equals 3. I will divide both sides by 3, so it will be x squared equals 1. So x is equal 1 or x is equal negative 1, because 1 to second power is 1 and negative 1 to second power is 1. So we have two critical values. Next, we will draw the graph of our first derivative function. So this is y prime is equal to 3x squared minus 3. We need x-axis. We have the roots, negative 1 and 1. We know that quadratic function, because we have quadratic function, has graph parabola. And because we have positive coefficient before x squared, it means the parabola is open up. And now this part is above x-axis, so has positive values. This part is under, so has negative values. And this part is above, so has positive value. So at 1, we change the sign from positive to negative. When we change sign from positive to negative, it means we have minimum. At negative 1, we change sign from negative to positive. It means we have maximum. When we change sign from negative to positive, we have maximum. So we have maximum and minimum. Now we have to calculate the value for negative 1 and 1 to find these points. So we have y of negative 1 is equal, I have to replace x by negative 1. So it will be 7 minus 3 times negative 1 plus negative 1 to third power. This is equal 7. Negative 3 times negative 1 is positive 3. Negative 1 to third power is negative 1. So this is equal 10 minus 1 is 9. So we have first point negative 1 and 9. And for that point we have maximum. Next, we have to calculate the value of our function y for x equals 1. So this is equal, we have to replace x's by 1. So it will be 7 minus 3 times 1 plus 1 to third power. This is equal 7 minus 3 plus 1. 7 minus 3 is 4 plus 1 is 5. So we have the second point. 1, 5, and at that point we have minimum. Now we have to find if our function has inflection points. So it means first we need to find the second derivative. The second derivative, it means we have to find the derivative of our first derivative. So we have 3x squared minus 3. The derivative of 3x squared is 3 times 2 times x. Derivative of constant is 0. So I don't have to write this. So this is equal 6x. When we have the second derivative, we have to set the second derivative equals 0. So this is when 6x is equal 0. We have to solve this linear equation, so x is equal 0. Now we have to check if for x equals 0 we have inflection. It means we have to check if our second derivative change the sign in a small distance to either side of x equals 0. To do this, the easiest way, in my opinion, is to draw the graph of the second derivative function. So we need xy coordinates. X, y, in our case is y-b's. Our function is linear function. Y-b's equals 6x. Because we have positive coefficient before x, it means our line is increasing. We have the roots, 0. So we have to just sketch this graph to see what happened at the 0. We see we have on the right side of 0 positive values because this part is above x-axis and this part is under x-axis. It means has negative values. So at 0 we change sign from positive to negative. It means we have inflection points. So we need to calculate the value for x equals 0. So we have y of 0 is equal, we have to go to our function. We have formula 7 minus 3x plus x to third power. It means we have to replace this x's by 0. So we have 7 minus 3 times 0 plus 0 to third power. This is equal 7. So we have inflection point 0, 7. This is our inflection point. This is my solution.